Good day everyone. My report is about the other time study methods. So, one time study method is elemental time data. Elemental time data establishes standards based on previously completed time studies stored in an organization's database. In elemental time data, many jobs consist of the same work element. For example, in many jobs, the secretary or the operator has to reach for materials, position an item, or insert and tighten something. So instead of recalculating that time, it should take to do a particular work element. And the time study analyst checks the database for valid time study. So the another time study method is predetermined time data. Predetermined time data is a published database element time data used for establishing standard times. So predetermined time data, it is a large database of valid work element. If elemental time data is useful for individual companies, the predetermined time data is useful or are useful for many companies that share similar work elements. So in addition, in 1940s, one commonly used system is methods time measurement. So another time study method is work sampling. Work sampling is a technique for estimating the proportion of time a worker spends on an activity. So work sampling, it is a method used for estimating a proportion of time that an employee or a machine spend on different work activities. So for example, in employee, the secretary may spend the day generating letters. So work sampling does not specify how long it take the secretary to generate a particular letter, but it does say what proportion of time is typically spent on generating the letter. So another example is in machine. For a machine, so many companies may use work sampling to determine what proportion of time the machine is used for rush jobs. So there are procedures in work sampling. So first, identify the worker or machine to be sampled. Second, define the activities to be observed. Third, estimate the sample size based on level of accuracy and confidence level. Fourth is, develop the random observation schedule. Make observations over a time period that is representative normal work conditions. Fifth, make your observations and record the data. Check to see whether the estimated sample size remains valid. Lastly, estimate the proportion of the time spent on the given activity. So those procedures are so important to know the technique for estimating the proportion of time a worker spent on an activity. So I have here example. So in this example, we will compute the estimated proportion of time or the observation. Work sampling example. we are interested in estimating the proportion of time spent by secretaries arranging and scheduling travel. We are considering the possibility of bringing an on-site travel agency to free up secretaries from this time-consuming task. We estimate that the proportion might be as high as 0.50. So, first step here is we need to estimate the number of observations needed to provide an estimate with 97% confidence, or Z is equal to 2.17. So, Z is our number of normal standard deviation needed for desired confidence. And the resulting estimate will be within 5% of its true value. We use N for our number of observation greater than or equal Z, our number of normal standard deviation, over E, our error levels, and our error level is given as a percentage, squared times P for proportion times 1 minus proportion. So this formula will help to estimate the proportion of time or the observation. So now we have to substitute. So 2.17 is our number of normal standard deviation, over our error is 0.05, squared times our proportion 0.5 times 1 minus our proportion 0.5 is equal to 470.89 observation. So to have a clearer solution, 2.17 over 0.5 squared is equal to 1883.56, and 1 minus 0.5 is 0.5 times 0.5 is equal to 0.25, and 1883.56 times 0.25 is equals to 470.89. So our observation is 470.89 observations. Second step is, based on the first 30 observations, the secretary was making travel observations 6 times, or 6 out of 3 observations, or 6 divided by 30 is equal to 0.2. With this new estimate, recalculate the sample size needed. So again, we have to substitute N, our number of observation, greater than or equal to 2.17 over 0.5 squared times 0.2 times 1 minus 0.2 is equal to 302 observation. To have clearer solution, 2.17 over 0.05 squared is 1883.56, and 1 minus 0.2 is 0.8. 0.8 times 0.2 is 0.16. 1883.56 times 0.16 is equal to 301.36, and if we rounded it off, we will have 302 observations. Our final step, after making the 302 observations, the secretary was making observations 60 times, or 19.9%. So this estimate can be now used to make the decision that might result by consolidating the task with an house travel agency. So thank you for listening. That's all.